x to the third y to the first, it's kind of two separate problems. You have this part, which is 8 minus 3, and then you have this part, 3 minus 1. So it's x to the fifth times y squared.
Okay.
Okay, so so the property, actually I didn't even write that. So this is what I would put on a reference sheet if you needed one, is the actual property. Something like this: when the bases are the same and you're dividing, you subtract the exponents.
Okay.
So the thing is, though, is that like you're never going to get if you were like, let's just say we could go back to wherever you were learning this in school, is you would never be given, like, you would not get a question like this on the exam. You would, or quiz, you're going to get, once you get past section 1, it's all synthesis. So you'd get a question more like this: 4 to the third times 4 to the eighth divided by 4 to the sixth. Okay, and this synthesizes, combines, what we learned last time and what we're talking about this time. So when you look at this, and this is very important for me to hear from you, is like, what do you want to do first? How do you want to work through this problem? And there's actually several ways. So what do you see?
I'd probably do the top first.
Yes, that's a good choice here. So the top would become 4 to what power?
11.
11. Bases are the same, add the exponents. Okay. And then from here, you can say, okay, well, I subtract, so that's 4 to the power of 5.
Right.
Now, there's actually no order of operations, and I guess we haven't talked at length here how much you like math relative to other subjects, but this is kind of an interesting thing, because in math, usually you're like, oh, there's an order. With these exponent rules, there's not. And the reason I brought up, like, do you like math? This is one of those things where if you're interested in math, like, this is one of those things that's like, oh, it's kind of interesting because, why wouldn't it matter? Because it seems like it always matters.
Mm-hmm.
So let's look at the problem again where we do it differently. So let's say we look at like this piece first. So that would be 4 to the 8 minus 6. And I'm just going to bring over this 4 cubed. So this part right here is 4 squared. 4 cubed times 4 squared is 4 to the power of 5. Notice that these are the same.
Okay. So it doesn't matter which way you do it.
It does not. You get to choose, which could be better, could be worse. Depends on, situation. Like when you're playing basketball, there's situations where you're forced into one thing.
Right.
If you're double teamed, usually you pass. But if you get the ball, you're wide open, you might shoot, you might pass. Who knows? Like there's options here, and I think that's important, for you to realize, is there's not always one path to go down.
Okay.
All right, so a couple of variations on this rule that we haven't looked at yet. I'm looking, and by the way, I'm looking at your page. I don't know what page it is. I don't know. It's the exercises page, but what I'm trying to do here is like look for ones that are odd that might prove to be confusing. So let's say I gave you 6 to the 4th times 1 over 6 squared. Are you comfortable with the fact that this is really 6 to the 4th over 6 squared? This is what I call a rewrite step. You're not actually doing any math. You're just changing it.
Yes.
Okay. So this would be 6 squared. Great. We've not talked about negatives yet, so let's try one of those. Let's say it's negative 3 to the 8th over negative 3 to the let's go 4th. Okay. So we talked about this a lot last week. It's the negative 3 inside parentheses that's all to the power of 8. And same thing down here. We'll do an example where it's not like that. But in this case, you just apply the same property that we did before here. So it would be parentheses negative 3 to the power of 4. You just subtract the exponents. Now, the question for you, this is from last week, is the answer positive or negative? And notice I'm not asking you to actually figure out what it is. It's just the sign of it. And it's based on this number right here, the exponent, and the
Yes.
fact that it's negative in there. Can you tell me?
It would be positive, correct?
Positive because it's an even exponent.
Yes.
Okay, very good. All right, now let's look at a kind of a related question here, which is let's go, I don't know, -9 to the fourth over -9 squared. In the numerator, you have to be very clear that it is just the 9, that is just this 9 that's being raised to the power of 4. And down here on the bottom, that is just the 9 being raised to the power of 2. So for example, you could rewrite this like this, which I think is much more clear. And if you see that, then maybe you also see that these cancel, the
Right.
negative ones cancel, and use the exponent rule here. So this is 9 squared, which is 81.
Okay.
Now, I feel like I went through that a little bit quick, but maybe this is all review. Were there any examples that you would like me to go through again, just for clarity? Because I'd like to give you some practice problems here based on these.
Are you talking about examples from that page I sent you?
No, just the ones that I did. I want to give you some like it
Oh.
and see how you do. But this is your chance to say, I really didn't understand that, or I'm not sure, or hey, you just want to try some problems on your own.
Could I maybe try the ones where we have to combine what we did last week? So like the second problem that we did?
Sure. So let me make a few of those up here. Let's go x to the 7th times x to the 8th over x to the 12th. And I'll give you another problem here. Let's go minus 12 to the 9th over minus 12 to the 7th. And let's make one more problem here. We'll go number 3. Okay. A couple of problems for you to try there.
Okay. Okay, so for number 1, I got x to the 3rd.
Okay.
And then number 2, I got 12 to the 2nd.
Okay. If you okay, so for number 2, if you were to, let me just write down here. If you were to write this, and this were like a 10-point question, I'd probably give you 7 out of 10, somewhere around there. I'm trying to indicate that like it's not complete,
Okay.
because you can actually simplify this, and in some of the
Oh
problems I
yeah,
did
you
do
did.
that. But maybe more concerning here is I would want to see this as an intermediate step. And I don't know if you wrote that, because I can't see your screen, but or paper. But and yes, this is 12 squared. But what I'm really looking for is, imagine, what number goes in this box that I mark right or wrong.
Are you asking?
Yeah, I'm asking. Yeah, like what
It
is the
would be
final?
144.
Perfect. Very good. Okay. All right. And let me know when you got number 3 down.
And then number 3 is 1 to the 4th.
So I'd probably deduct here. Can you simplify this a little bit more?
Yes. It's just 1.
It's just 1. Yeah. Okay. Now we covered a few other rules last week, which we probably ought to talk about here again. So let's say it's like x squared to the power of 4 over x to the sixth. Um, Here, if you recall, when you have an exponent to an exponent, you first multiply them. So this is x to the eighth over x to the sixth, which is x squared.
Right. Okay.
Okay. Um, we can, further combine some things here. So it's like x to the seventh, y cubed to the power of 2 over x cubed y to the fourth. So do you remember how to apply this 2 to each of the exponents here?
Um, wouldn't you multiply both of the exponents? Like, wouldn't
Yes.
you?
Yes. So x to the 14th, y to the sixth over x cubed y to the fourth here. So now it's really two separate problems. It's this x's and this y's. And so what?
You would subtract the exponents, right?
Yeah, so you get x to the 11th, y squared. Okay.
Okay.
And then we also talked about how to deal with like numbers. Let's say it was like 4x to the power of 3 over 16x squared. What do you do in the numerator? How do you apply this 3? You got a 4 and an x here. Do you remember how you apply them? And I'm really asking, what is the unwritten exponent that you're
It's
supposed to?
1.
It's 1, yeah.
Yeah. So then you just multiply.
So what would go in the numerator?
Um, 4 to the third,
Mhm.
x to the third.
Okay, over 16x squared. Now 4 to the third, we can reduce that. What is 4 to the third?
Um,
4 times 4 times
4.
4. 64 over 16 x cubed x squared.
Okay. And then you would subtract the 3 and the 2, correct?
Yes.
Okay.
But you can also divide here.
And that would be 4.
Yes.
So it would be 4x, just 4x.
4x. Perfect. Okay. So the fact that there's a number up here in the exponent, you apply it to each of these. Now there's another property, kind of. I mean, they're all sort of properties, but it's usually written like this: a over b to the n equals, and there's really a 1 here and a 1 here. It's a to the 1 times n, b to the 1 times n. And it's usually written like this, but what you're supposed to see is that you're actually applying this n to both exponents. Okay, so this is your kind of your new property here, and it's usually better to see an example than to see the symbolic form. So
Right.
it's more like this. It's like 2/3 to the power of 3. So there's really a 1 there and there's really a 1 there. So this is 2 to the 1 times 3 power, which is 2 cubed, 3 to the 1 times 3 power, which is 3 cubed, 2 cubed is 8, 3 cubed is 27, and that's your final answer. But the point is that this exponent now, when there's a fraction inside, you apply it to both the top and the bottom.
Okay.
So let's say I give you something else, like x squared over y to the fourth to the power of 10. This 10 applies to both the numerator exponent and the denominator exponent.
Okay.
So it'd be x to the 20th over y to the
40.
40th.
Okay.
And if you have numbers, it also applies to the numbers. So like, let's say it's 2x to the third over 3y squared all to the power of 5. Okay. So this time, this 5 actually applies to the exponent of the 2, which is a 1. We don't write. It applies to the 3. It applies to the 1, which is the exponent of the 3. And it applies to the 2. It applies to everything.
Okay.
The 2 to the 5th, x to the 15th, because you multiply. 3 to the 5th, y to the 10th.
Okay. And then you can combine the 2 to the 5th and the 3 to the 5th, right?
Well, you could only if the bases are the same. The exponents being the same is not a
Oh,
good,
okay.
and you may know that, okay, 2 to the 5th is 32. Maybe you might look at that reference sheet I sent you. 3 to the 5th is kind of right on the edge of what you might know if you were to study this.
Yeah. Okay.
So there's a lot here, and I would like you to try one on your own now. I won't make it as difficult as this, but
Okay.
the goal here is to get you to be able to simplify something like this on your own. So 3n squared over m to the power of 4. So try simplifying that, please.
Okay. Okay, it would be 81n to the 6th over m to the 4th.
Okay. So the only issue is this right here, this number 6.
Oh, I think I added instead of multiplied.
Yes.
Okay.
Yes.
Then
So it should be an 8.
into the 8th. Yes. Okay.
So what that reveals to me, and I mean, this kind of a standard thing in math, is like the little building block that you know how to do that, and there's another little building block and you know how to do that,
Mhm.
and but it's the synthesis, the combining of them, that's hard.
Right. Yeah.
And we'll make an analogy to basketball. Probably the first time you did a bounce pass many years ago, it was hard, but
Hmm.
you practice and it becomes easier. I mean, there's no substitute here for doing some practice on these.
Right.
So let's try another example here. Let's see if I can get you to do it. Let's go 5x cubed over 6y squared to the power of 7. And this time you do not simplify the numbers. Just write them
Okay.
with the exponents.
Okay. So it would be 5 to the 7th, x to the 21st over 6 to the 7th, y to the 14th.
Perfect. Okay,
Okay.
very good. All right, so now we're gonna look at something slightly different, but related. Is like, let's say I do this. I write -1 over x to the power of 3. Okay, and this is where we're really relying on your understanding of a few things from last week and now this week. What is being applied to the power of 3 in the numerator is -1. Even though it's not written, there really are what I call implied parentheses.
Hmm.
And when I say implied, I mean you're supposed to know that they're there, even though they're not written. So you can make the argument like, why aren't they written? Well, it's for compactness. But
Yeah.
as a student, you have to say, oh yeah, this is what is really meant by that. Okay. Um, in the bottom, you are actually applying the 3 to the 1. So I asked you earlier, negative 1 to the power of 3, is that positive or negative?
Negative.
It's negative. Negative 1 over x cubed. Perfect. Okay. Now, this is exactly the same problem, but it's written slightly differently. Okay. Now, this negative in the front, there's actually, so let me come off to the side here. Do a little aside here. So the following are equivalent: negative 1/2, negative 1 divided by 2, 1 divided by negative 2. These are all the same.
Right. Okay.
In general, there's a preference, kind of like your preference is like this, then this
Mhm.
one, then this one. Um, Preference in math means like what your teacher expects you to write. For clarity, I think it's better to put the negative in the top, but textbook problems will put the negative wherever they see fit. So
Right. Okay.
just, be aware. So like the reason I bring that up is what you could do is you could rewrite this as negative 1x cubed, and then it's just like the problem we had. Or you could say, well, I'm going to apply that 3 to the 1 and I'm going to apply it to the negative. You have choices. And it really comes down to like what you prefer.
Okay.
Um, but the answer is the same. It's still this.
Right. Okay.
Okay. All right. So let's look at another problem here. Let's look at, let's see here. So kind of interesting is your book gave you some problems like the following, like this.
Right.
And they're kind of like the problem we just did. You have to say to yourself, okay, it's that negative 4 to the power of 4, and then it's 3 to the power of 4. And even though the exponents are the same, you can't do anything with the bases. You have to just work them out.
Yeah. Okay.
And then this is 256. So let me have you try one here on
Okay.
your own here. Let's go with 7 over negative 9 to the power of 2.
You want me to simplify it all the way, right?
Yep. Give me, imagine there's a box here where you're going to put your final answer in, and that's all I'm going to grade, which isn't
Okay.
really fair to you as a student, but let's just, let's pretend like that is.
Okay. Okay, so it'd be 49 over 324.
Okay. How did you get the number on the bottom?
I multiplied um 18 and 18.
Okay.
Oh, I
Okay.
think I
I can see why you would do that. The sort of the intermediate step here is that it's 7 squared over negative 9 squared. And 7 squared is 49. That part was fine. But this is like negative 9 times negative 9.
okay. I think I just did 18 and then I just carried the 2 over for some
Yeah.
reason.
Yeah. That's something that students will do. Is and the most common one is something like 2 cubed. Instead of saying, oh, that's 2 times 2 times 2, they write 6 because it's 2
Yeah.
times 3.
Mhm.
I I don't know how to fix that. That's like a,
I think it's like a brain thing.
yeah, and um, you know, it's not like in sports where you can get away with doing something wrong because you just it works. It's math, if it's wrong, it's just wrong.
Yeah.
Uh, so somehow you have to convince yourself. The where you'll see this that's most problematic is, let's say, and I assume you've seen something like this before in school. Um, the instructor will say to simplify this. The correct answer is to write it out like this on the right and then
Yeah.
FOIL. It is not to just square and square, and that's it's kind of like that. There, you have to know to write it out longhand before you can
Yeah.
make that. All right, let me go back here and look at a couple more examples here. All right, let's look at. So we're getting close to like what I would consider to be like a quiz-worthy question,
Okay.
which means that like a lot of what we've done is just building up to like the real problems you need to do. So could you look at this problem and just you don't have to do it, just tell me what you would like give me like your first step. Like what do you see? What do you think is the
Um,
right thing to do first?
I would probably multiply the two exponents,
So like this
like
two with this
the
two.
two and the two. Yes.
Okay. What other exponents would you multiply?
Um, the the one and the two, the one being from the three,
Yes. And
and
then
then
also
the
yes.
three and the two.
So that would give you x to the fourth over 3 squared over y to the sixth.
Yes.
Now, based on what we have done so far, would you give full credit for this answer?
No.
Okay, I agree. What can you do to sort of make it pretty, to like make it in the preference that we expect?
Um,
It's this
do
right here.
yeah. I don't know how to really say that, but yeah, do that.
Okay,
So that become 9.
yes. Okay, so let's try another one here. Let me have you try this one on your own. Let's go 7x to the fourth over y squared to the power of 2. I'd like you to try this problem on your own, please.
Okay. Okay, would it be 49x to the 8th over y to the 4th?
Perfect. Yeah, that's correct. So now we're going to go just a tiny bit longer. Just want to get a few more examples in. Um, P over Q, Q to the power of 3. Can you tell me what this simplifies to?
Um, p cubed over q cubed?
Yes. You might be thinking, well, why are you asking me that, Matthew? I'm like, well, and here's why. Because I want to do a related problem that you already know how to handle this piece. So this piece right here is exactly what you just did.
Okay.
So you have to, as a student, realize, okay, I do one part of it first, and then how do you handle what's left here?
Yeah.
So what I'm hoping you're seeing is that, well, this p is in the numerator. So because you're multiplying, what do you do to the exponents? What is the rule? Do you recall?
You add them.
Add them. So p to the fifth q cubed. Okay. So if you understood that, let me have you try a new problem here. Let's go
Okay.
m to the fourth over n to the sixth squared times m cubed n to the ninth.
Okay. So it would be m to the 9th over
Is that your
um,
final answer?
m to the 9th over n to the 21st, I think.
Okay. So let's look at this. What did you do with this 2 here?
I multiplied the 4 and then the 6.
Okay, so it
6.
became m to the 8th over n to the 12th times m cubed over n to the ninth. Do you want to change anything over here about your final answer?
I do.
Okay, what would you like to change?
Okay, so it would be m to the 11th
Yes,
over m to the n to the 21st.
perfect. All right, good job. Okay, so my recommendation is to have you do the odds uh, on your
Okay. Okay.
yeah, and the way that I like when I see stuff like this, uh, what I recommend skipping are the ones that are like error analysis or the multiple choice. Like you just want to do the ones that are kind of the pure, like I'm looking at like 21 through 36.
Okay.
Those are the ones that you really have to have dialed in and know how to do. Um,
Okay.
and I would recommend maybe taking a break, trying them later today, but
Okay.
don't wait too long.
Right.
Um, are you available for a lesson next week, or are you gone for the entire week?
I come back Thursday night.
Okay, so I'd be happy to help you again, but it probably won't be until the week of the following week of
Okay.
July 4th. So maybe we can do something on Tuesday or Wednesday of that week.
Okay. Yeah, that sounds good. And basketball is over
Great.
then, too, so whenever.
Okay, sounds good. So I will send you the notes and a link to the screen recording here shortly. And
Okay.
I'll see you next time. Hope you have a great day.
Thank you.
You're welcome. Bye now.
Bye.